Hi everyone, this is one of the homework problem currently, and then I generate this animation to kind of help you to understand the situation a little bit. So this is a problem, and fz is this rational function in this complex number z, and I did the partial fraction decomposition for you. So it kind of, from here you can easily see the singularities, but it's kind of separated over the sum, so the integral will behave nicely, so kind of you can integrate over this term and over that term separately. So that's one hint. And if you use Mathematica and sketch this function parametric curve from negative pi to pi, and then it looks like this. I'm going to pull it up a little bit more so it looks like this. So integrating all along, and this complicated loop itself will be very difficult. Again, the function here is analytic, except that these 2 points, so those 2 points are 1 and negative 1 happen to be real number. Negative 1 is here and positive 1 is there, so outside is analytic. So if you use Green's theorem 2 or Cauchy-Goursat theorem, then something is going on in the complicated part. It is not just a one loop, it's just overlapping like that. So I generated this animation to hope you see this little transformation, little contraction or deformation of this curve doesn't really change the integral value. I hope you got that kind of intuition built up by looking at those Green's theorem second version or Cauchy-Goursat theorem. So here's the animation. So by changing a little bit of parameter there, I changed this curve into slightly different form. As you can see, all these curves are quite similar to each other, and as you deform these curves slightly by these small factors, it's not going to change the integral value. I hope that's kind of intuitive, but when you prove it, you can kind of dissect or divide this and these curves into different pieces. For this particular piece, you can make your argument a little bit more rigorous than what I said here. And but this is a cool animation that I'm showing here. Kind of shows you that very tiny difference, and you think about what's going to happen to the integral value as we change these things like this. And if you believe it doesn't change, from that belief you can kind of formulate your answer and try to make your answer solution a little bit more rigorous than what I'm just saying here. Good luck.